All right, today we are going to solve radical equations. Anytime we solve anything, we're looking for the mystery x. Who is x? Is x 5? Is x 10? Is x 4 radical 2? What is x? So we are going to have equations all of a sudden, not just expressions. So everything today will have an equal to a value, such as that example right there. So by definition, a radical equation is an equation that contains a variable under the radical symbol. And the hint we have is to take care of Klingons first. And what I mean by Klingons is just like with solving any equation, you're trying to solve for x. So you're trying to isolate that x. So Klingons would be this guy's clinging on and this guy's clinging on. You want the square root of x by itself. So let's take care of both of those Klingons. Which one do you think we take care of first, the 8 or the 2? 8. We're going to take care of the 8 first. You could divide everything by 2 at the beginning, but remember, divide everything by 2 if you're going to do that. Much easier to take care of the addition or subtraction first. So let's do that. Now we can take care of the 2. How would we get rid of that 2? Divide both sides by 2. So now I have the square root of x equals 4. Now before you just automatically say 2, because you know that that's, oh no, that's not going to be 2. You know that's going to be 16, right? Because that's an easy one to find. But let me show you how to do it if it's not one that's real obvious. How could I get rid of this radical sign? Yes, square it. Since this is a square root, to get rid of it, I'm going to square it. Well, guess what? If you square one side, you've got to square the other side. So this radical sign and this squared sign cancel each other out, and the x just falls out. And then x is 16, which you already knew, but that's the process which we go through. So to undo a radical sign, you raise it to the second power, and it'll undo it. Okay? So let's get into some, okay, you got to be careful when you do radicals. You've got to check for extraneous solutions. Do you remember what extraneous solutions are? We've had them in the past. They look like solutions when you solve, you get it, but then when you plug it back into the original equation, it doesn't work. So you have to kick it off. So an extraneous solution is it works mathematically until you try to check it in the original, into the original equation. And you can find them a lot here because squaring both sides can result in a false solution for the original equation. It's false because it doesn't work in the original equation. So let me show you how do you check, or how do you know if your solution is extraneous. You blank your solution back into the original equation. What are we going to do in that blank? What verb is going to go in there? What are we going to do? Plug, baby. Plug and chug. Yes. Plug your solutions, both of your solutions. We're going to plug them back into the original equation to see if they both work. And if one of them doesn't work, the axiom off the island. So let's keep that in mind as we start doing this. We're gonna check them when we're done. All right, here we go. Square root of x minus 7 equals 0. We'll start off nice, slow, and sweet. What can we get rid of first? What Klingon? So I'm going to add 7 to both sides. So the square root of x equals 7. Then I want to get rid of that radical, even though I know the answer is 49, but I want to get rid of that radical, so I'm going to square both sides, which will cause the x to fall out, and 49 would be my answer. So let's just do a check real quick. If I put 49 in there, I'll get the square root of 49 minus 7 equals 0. Well, the square root of 49 is 7. 7 minus 7 equals 0. That is true. That does work. So I'm good there. No extraneous solutions. I only have one answer. All right, the next one. What Klingon do you want to get rid of first? 3? Let's get rid of the 3.
Have a good day.
You too. So on this one, if you try to divide by 12, and this is where kids kind of get mixed up. If you try to divide by 12 first, they forget you have to divide 3 by 12. Now you're working with a fraction. Who wants to do that? So let's get rid of the 3 first. Now we can get rid of the 12. And this is going to be, when I reduce that, negative 1/4. So again, I want to get the x by itself, so I'm going to square both sides. X will fall out. And this will be negative 1/4 times negative 1/4 would be a positive 1/16. So this is what I think the answer is. But I don't know for sure. I'm going to check it into the original equation. So that would be 12 times the square root of 1/16 plus 3 equals 0. So let's get the square root of 1/16. Square root of 1/16 would be the square root of 1 over the square root of 16, right? So the square root of 1 would be 1, square root of 16 would be 4. And 12 times a fourth is 3. 3 plus 3 equals 0. That does not work. 6 does not equal 0. So we vote this guy off the island. So what does that mean? What's my solution then? There's no solution. This problem has no solution. So don't be surprised on your tests on Friday or on your homework tonight. You'll have some that don't work that have no solutions, and that's okay. It's what happens sometimes. All right. Let's go with this one. This one, what's different about this one and the ones we've been doing? Yeah, underneath the radical you have more than just an x. But that's okay. We're going to work it the same way. Let's get rid of the 12. Just keep the whole x minus 7 under your radical house. Divide both sides by 4. So we're going to do the same thing to get rid of this radical sign. We're going to square both sides. But now instead of just an x falling out, the whole x minus 7 falls out. Which causes one more little step. I'll need to add 7 to both sides at the last minute. So I'm thinking x equals 23. That's what I think the answer is. So let's go over here and check our answer to make sure. So the check over here would be 4 times 23 minus 7 plus 12 equals 28. So this would be this 23 minus 7 is that 16?
That works.
16. And the square root of 16 is 4, so this is going to be 4 times 4, which is going to be 16 plus 12. Ooh. I think it's going to work. It's 28. Life is good. So 23 is indeed our answer. So not too hard. It's not bad at all. A couple more here. Now, this one is a little different because we have radicals on both sides. There are no Klingons, so to speak. So Amanda, how would we start this problem? How would we get rid of those radical signs from the very beginning?
You would get the radical on each side, so
So how do we get rid of this?
square.
We'll just square both sides from the very beginning. So from the very beginning, I'm going to square both sides. The guts are going to fall out of both of them. Everybody comes out of the house. 3x minus 17 comes out of the house, and x plus 21 comes out of the house. Now I've got a very simple two-step pre-algebra problem. I'll subtract x from both sides. I'll add 17 to both sides. And then I'll divide everything by 2. Come down with a 19. But of course I need to check to see if that works. So the square root of 3 times 19 minus 17 needs to equal the square root of 19 plus 21. So this would be the square root of 3 times 2 on this side. So that's the square root of 6. I don't really need to find that. We'll just leave it square root of 6. Over here, this is the square root of 9, 10, carry the 1, square root of 40. Would that work? Is the square root of 6 equal to the square root of 40? Even if I break this down into 4 times 10, it would be 2 radical 10. Did I do something wrong?
Why don't you have to multiply 19 by 3 before you subtract 17?
Wait, what do you mean? Oh yeah, it's 3x. I put the parentheses in the wrong place. My bad. Woo-hoo. All right, so 3 times, what are we doing? 19 minus 17. Okay, let's try that. What is 3 times 19? 57 minus 17? 40. Oh, it does work. All right. Good. And once you see that you have the same, you can break it down if you want to, but you don't have to. Once you get to something equals something, we're good to go. So yes, one answer. One answer. Yeah. What do you think you'd do with this before you start? Maybe. Yeah, I'd probably bring this guy over here so that I would have a radical on each side. So I'd have a radical here, and this guy would go over as a positive radical. Now I have a problem just like the last one. I'll square both sides. Quickly. I'm giving a 1. Check it real quick. 4 times 1 is 4. And that's going to work. Square root of 1 minus square root of 1 equals 0. Some of them are pretty easy to check. Others aren't. A little bit more difficult, but so that's so remember to do that if you need to. How about this one? What would I do? Square both sides. But watch what happens on this one when you square both sides. Yes, this falls out. And this becomes an x squared. Well, wait a minute. X squared is a quadratic. So, how do you solve a quadratic? What do you try to get on one side? So you can factor. Try to get a 0 on one side, right? Because quadratics, you're looking for solutions which are x-intercepts, which the y, oh yeah, we need a 0 on one side. So I'm going to bring all this stuff over here. I would suggest whenever you have a quadratic, bring it all to the positive side. You want your x squared to be positive. So I'm going to get a 0 on this side. I'm going to bring this x over, which would be a positive x, this x over, which would be a negative 6. And it's a trinomial with no leading coefficient. And I bet you I can find factors of negative 6 that add up to a 1. I told you that this would never go away. It's going to be a negative 2 and a 3, right? So if blank times blank equals 0, one of those blanks has to be a 0. So I'm proposing x is either a 2 or x is a negative 3. Interesting. I think two things would work. Well, let's see. I might check. Let's go back to the original equation. And let's check the 2. So 6 minus 2 equals 2. That'd be the radical 4. That works. Because 2 is going to equal 2. So 2 is good. Let's check that negative 3. Square root of 6 minus negative 3 equals negative 3. So this is the square root of 9, because this negative would be plus, equals negative 3. Square root of 9 is a positive 3. That does not equal a negative 3. So that means 3 is extraneous. You do not even mention it. This problem only has one answer, and it's 2. So we've gotten, you have a possible, you could get 2 answers, you could get 1 answer, or you could get no answers. That's why it's important to check extraneous for extraneous. That one would work the same way. Square both sides. I'm just going to do this real quick. You can need to do this one if you don't want to. Just going to do it one more time. So the 3x plus 4 would fall out. Again, I'm going to bring everything to the x squared side. I'm going to factor this. What would that be? Minus 4 plus 1. So x is either 4 or x is negative 1. I think the negative 1's not going to work because right here you're going to get some square root equals a negative, and a square root will never equal a negative. That's the only solution. Okay? I think we're good. I think you got it. You got 45 minutes. Get her done. Nobody wants homework this time of year.
Oh boy.